Okay, so how are we going to write equations if we don't have matching, if we can't like try and figure out from something that they've already given us? What we need to do is first determine the parent function. We have to know what the parent function is. Is it a linear? Is it a quadratic, exponential? What does it look like? After we do that, we have to figure out the transformations, and that's going to give us the entire function. Did it go up, down, left, right? Did it reflect? And then the last thing we have to do is determine the specified domain. So we have to figure out where does it want this particular function. So let's look at this first example. I'm going to name him f of x. You should see that f of x has two pieces, right? So we have this piece and we have this piece. Now this piece has a closed circle on it, so we have to keep that in mind when we look at that. So both of these, well, no, let's just start with the red one. This is a linear function, so I know it's just going to be like x, right? But it's not a linear function that would have gone through the origin. So where did this one go? And I don't know why like this isn't here, but if we I just muted myself. Okay. See how this one, if I kept going, it would be, the y-intercept would be up here. That means the transformation was up 1, 2, 3, 4, 5. So it went up 5. And then because we're just going up 1 over 1, it didn't stretch, so that's the function with its transformation. So what's the domain? Where do we use this function? Well, it's when x is, so see how this is at -2? It's where x is less than -2. It's just less than because it's an open circle. If it was or equal to, then we would have a closed circle. All right, so let's look at the second function. Hopefully we know that this is a constant function. So those are pretty easy to write. It's just a number. That's it. No x's. If there's an x in there with a constant function, you just change it to a linear function. So what's the number? Well, the number is -2. Where do we use just -2? By the way, I know it's -2 because it went down 2. So this is at -2 the whole time. It's when x is greater than or equal to -2 is when I use this specific function, where it's greater than or equal to. So first of all, it's greater than because it's going to the right. Secondly, it's or equal to because we have a closed circle here. Now, you can't use this ahead of time, but you can check in Desmos to see if this is the right function by graphing what you have gotten. So you can check your work that way, but you can't actually produce an answer that way. All right, last one. So I'm going to start by creating a function. I'm going to name him g of x. Now notice that g of x here has 3 pieces. We have the red piece, we have the blue piece, and we have the green piece. All right, so I'm going to start with this red piece here. So the red piece is a linear function, so it's going to be x. It might just be x. It could be 2x. It could be 1/2 x. We'll figure that out in a second. Let's look at the transformations. Well, usually linear functions or the parent linear function goes through the origin. So see how this one has been transformed up 2 units? So I'm going to put +2. All right, let's see if there's anything else that's happened. Usually we would go up 1 over 1. Here we go up 1 over 2. So actually 3, isn't it? Yep. Up 1 over 3. So what that means is it's been vertically compressed by a factor of 1/3. Or the slope is 1/3. It's a little bit difficult to see this. This one is going to be my closed circle. There's also a closed circle on the green function. And the blue function has open circles. Just wanted to mention that before I keep going. For this specific domain of this red linear function, it's where x is less than or equal to 3. So this is 3, right here. And so it's here and then to the left. So less than or equal to 3. All right, let's do the next function. So we can hopefully see the curve in this function. That's a quadratic, x squared. But this has moved a couple places. So I'm going to have to do something with that x squared. I'm going to have to move this function to the right 4 and up 2. So to the right 4, let's think about that. That's going to be x minus 4 squared. Remember when we move to the left or the right, it's inside with the x. And then up 2 on the outside. Now we have to figure out where is the domain defined, and it's from this point 3 to this point 6, but neither of those points are included, so we would say x is in between 3 and 6. All right, now our last function is this green one, and we should hopefully see that this is a linear function. So I'm going to start with just my x. That's the parent function of a linear function. If I were to extend it, this would have a y-intercept up here. So this one was transformed up at 12. But notice that the way that this function is going, it's going down, and so that would be a negative. So it reflected. The domain that this is defined for, let me erase this part, is from x is greater than or equal to 6. So this, starting at the 6, is when we pick up the green function. So that's, in a nutshell, how to create the equations of piecewise functions given the graph.